Good day everyone. By the way, I am Ailyn Rayoso, a second-year student taking up a Bachelor of Secondary Education major in Mathematics. At the end of this video presentation, you will be able to learn how to solve integrals using the method of integrating by parts. Additionally, you will learn how to use the disk and washer method to solve for the volume of the solid of revolution. The first instruction is as follows. Among the four techniques, integration by parts, trigonometric integrals, trigonometric substitution, and partial fraction, choose one of the techniques and discuss how to solve the integrals. So, I would like to remind all of you to please bear with me as we figure out the integral of this particular problem. The problem is to find the integral of x cubed over the quantity squared of x squared plus 2 dx. This integral can be computed using at least three different methods: substitution, partial fraction, or integration by parts. But I'll show you the integration by parts here. First, let the first derivative of f of x equals x over the quantity squared of x squared plus 2 dx and g of x equals x squared. So to compute f, we need to integrate x over the quantity squared of x squared plus 2. And we can do that using the substitution by letting u equals x squared plus 2, du or the derivative of u equals 2x dx, and so dx equals du over 2x. When we substitute the values of u, du, and dx, the integral of x over the quantity squared of x squared plus 2 dx equals the integral of x over u squared times du over 2x. Using the constant rule, let's put the 1/2 outside the integral, and we will get 1/2 the integral of 1 u squared du. To simplify further, the result will be 1/2 times negative 1 over u plus c, or the constant, and the final answer will be negative 1 over 2 times x squared plus 2 plus c. Thus, if the first derivative of f of x equals x over the quantity squared of x squared plus 2, then f of x equals negative 1 over 2 times x squared plus 2. Proceeding with the integration by parts, we write f of x equals negative 1 over 2 times x squared plus 2. The first derivative of f of x equals x over the quantity squared of x squared plus 2. G of x equals x squared, and the first derivative of g of x equals 2x. Using the following formula, the integral of the first derivative of f times g is equal to f times g minus the integral of f times the first derivative of g, which will become the integral of x over the quantity squared of x squared plus 2 times x squared dx equals negative 1 over 2 times x squared plus 2 times x squared minus the integral of negative 1 over 2 times x squared plus 2 times 2x dx. By simplifying further, we have negative x squared over 2 times x squared plus 2 plus the integral of x over x squared plus 2 dx. And this second integral can be computed using the same substitution. Let w equals x squared plus 2, then dw equals 2x dx, and so dx equals dw over 2x. The integral of x over x squared plus 2 dx is equal to the integral of x over w times dw over 2 dx by substituting the values of w, dw, and dx. Next, following the constant rule, we have 1/2 outside the integral of 1 over w dw, which is exactly 1/2 ln of w plus c, which is the constant. And the final answer is 1/2 ln of x squared plus 2 plus c, when we substitute back the value of w equals x squared plus 2. So the entire integral will be the integral of x cubed over the quantity squared of x squared plus 2 dx is equal to negative x squared over 2 times x squared plus 2 plus the integral of x over x squared plus 2 dx. By substituting our obtained answer in the previous slides, we have the integral of x cubed over the quantity squared of x squared plus 2 dx is equal to negative x squared over 2 times x squared plus 2 plus 1/2 ln of x squared plus 2 plus c. To check whether our answer is correct, let us use the differentiation. The first derivative of f of x equals the first derivative of negative x squared over 2 times x squared plus 2 plus 1/2 ln of x squared plus 2 plus c, which is equal to negative 1/2 times 2x times x squared plus 2 minus x squared times 2x over the quantity squared of x squared plus 2 plus 1/2 times 1 over x squared plus 2 times 2x. Simplifying further, we have negative x times x squared plus 2 minus x cubed over the quantity squared of x squared plus 2 plus x over x squared plus 2, which is equal to negative x cubed plus 2x minus x cubed over the quantity squared of x squared plus 2 plus x over x squared plus 2. By simplifying further and getting the same denominator, we get negative 2x over the quantity squared of x squared plus 2 plus x times x squared plus 2 over the quantity squared of x squared plus 2. Then, distributing x to x squared plus 2, we get negative 2x plus x cubed plus 2x over the quantity squared of x squared plus 2. And by adding negative 2x and positive 2x, we get x cubed over the quantity squared of x squared plus 2. Therefore, our solution is correct. The volume of the solid of revolution. Here is the second instruction. Define your functions and describe them by graphing the functions and the area bounded by those functions. Formulate a problem that involves finding the volume of the solid of revolution using A. Disk method and B. Washer method. If possible, draw the solid of revolution. Here is the problem. Find the volume of the solids. Find the volume of the solid generated by revolving the region bounded on the left by the parabola x equals y squared plus 1 and on the right by the line x equals 5 about A, the line x equals 5 and B, the y-axis. Let us consider that a solid is generated by revolving a region bounded on the left by a parabola x equals y squared plus 1 and on the right by the line x equals 5. The graph of the curve is given in the figure on the left. So now let's find the volume of the solid whose revolution revolved about the line x equals 5 by using the disk method. If r of y equals to 5 minus y squared plus 1, which is exactly 4 minus y squared, then the volume by the disk method is v equals the integral of pi times r of y squared dy, integrating it from c to d, which are the lower and the upper limits. Substituting the value of r of y, which is equal to 4 minus y squared from negative 2 to positive 2, we have the integral of pi times the quantity squared of 4 minus y squared dy from the limits of negative 2 to positive 2. By following the constant rule, let's put the pi outside the integral and perform the FOIL method for 4 minus y squared. We get pi, the integral of 16 minus 8y squared plus y to the 4th dy, integrating it from negative 2 to positive 2. So now, let's integrate using the power rule of integration. We have pi times 16y minus 8y cubed over 3 plus y to the 5th over 5 from negative 2 to positive 2. By substituting negative 2 and positive 2 to 16y minus 8y cubed over 3 plus y to the 5th over 5, we get pi times 16 times 2 minus 8 times 2 to the 3rd over 3 plus 2 to the 5th over 5 minus pi times 16 times negative 2 minus 8 times negative 2 to the 3rd over 3 plus negative 2 to the 5th over 5. Then by simplifying, we get 2 pi times 32 minus 64 over 3 plus 32 over 5. And by multiplying 2 by 32, we have 64 pi times 1 minus 2/3 plus 1/5, which is equal to 64 pi over 15 multiplied by 15 minus 10 plus 3, which will give us the simplified answer of 512 pi over 15. So this is the graph of the disk formed by the line x equals 5 and the two graphs. If the region we revolve to generate a solid does not border on or cross the axis of revolution, the solid has a hole in it. The cross sections perpendicular to the axis of revolution are washers instead of disks. The washer area is A times x equals pi rx squared minus pi rx squared, where r of x, or the capital R of x, is the outer radius and small r of x is the inner radius. Volume by washers for rotation about the x-axis is given as V equals the integral of a of x dx from a to b, which is equal to the integral of pi times the quantity squared of r of x minus r of x dx, integrating it from a to b, which are the lower and upper limits. So in letter B, we need to find the volume of the solid generated by the revolving region about the y-axis. In this case, the outer radius is r of y equals 5 and the inner radius is small r of x equals y squared plus 1. So from the previous equation, we get the volume by washers method, which is V equals the integral of the quantity squared of r of x minus the quantity squared of r of x dy from C to D. Substituting the value of the outer radius and the inner radius, we have pi the integral of 25 minus the quantity squared of y squared plus 1 dy, integrating it from negative 2 to positive 2. Using the FOIL method on our given inner radius, y squared plus 1, we get pi the integral of 25 minus y to the 4th minus 2y squared minus 1 dy from negative 2 to positive 2. Simplifying it, we get pi the integral of 24 minus y to the 4th minus 2y squared dy from negative 2 to positive 2. Integrating using the power rule of integration, we have pi times 24y minus y to the 5th over 5 minus 2y cubed over 3 from negative 2 to positive 2. Substituting negative 2 and positive 2 to y, we have 2 pi times 24 times 2 minus 32 over 5 minus 2/3 times 8. So, multiplying 2 by 16, we get 32 pi times 3 minus 2/5 minus 1/3, which is exactly equal to 32 pi over 15 times 45 minus 6 minus 5, or 1088 pi over 15. Therefore, the volume of the washers formed by the y-axis and the two graphs is 1088 pi over 15. And so, this is the graph of a washer formed by revolving the area bounded by the graphs x equals y squared plus 1 and x equals 5 about the y-axis. Thank you for watching. Bye!